This is pre-algebra lesson 8-2, part 1, equations with two variables. A solution is an ordered pair that makes an equation true. An ordered pair, if you remember, is an x-coordinate and a y-coordinate written in order x comma y. A linear equation is any equation whose graph is a line. It comes from the root word line. Linear comes from the root word line, so it means equation of a line. To find a solution of an equation, you can simply substitute a value in for one of the variables and solve for the other. For example, if I say find a solution of y equals 4x minus 3 for x equaling 2, which means every time I see an x in my equation, I'm going to plug in a 2. So I have y equals 4 times x, which is 2, minus 3. So y equals 8 minus 3. So y equals 5. So a solution to this equation is 2 comma 5. 2 for x and 5 for y. So when I plug in a 2 for x, I get a 5 for y. So this is a solution to this equation. If I'm going to find a solution to y equals 2x plus 1 for x equaling negative 3, y equals 2 times negative 3 plus 1. 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5. So y equals negative 5. So a solution here is when x is negative 3, y is negative 5. So that's a solution. We look at problem number 3. Y equals negative 4x plus 3 when x is negative 3. So y equals negative 4 times negative 3 plus 3. Negative 4 times negative 3 is positive 12. Positive 12 plus 3. 3 is 15. So y equals 15. So when x is negative 3, y is positive 15. That's a solution to this equation. And last but not least, y equals 0x minus 4 when x is negative 3. So y equals 0 times negative 3 minus 4. So y equals 0 minus 4. Y equals negative 4. So when x is negative 3, y is negative 4. That is a solution to that linear equation. Notice I keep emphasizing that is a solution and not the solution. Right? Because depending upon what I put in for x, I may get a different value for y. For example, in problem number 4, if I put in 1 for x instead of negative 3 for x, right, I would get a different solution. I'd get 1, negative 4, which is different than negative 3, negative 4, which means there is more than one solution to a linear equation. Depending upon what you substitute in for x, you may get different variables for y, or the same variable, and or the same answer for y, but your x value will be different, meaning you'll get different solutions. Because of this, the easiest way to solve a linear equation is to graph it, because a graph shows you all the possible solutions very quickly. Okay? The best way to graph an equation is to make a table of values to show your ordered pairs. You might say, what in the world is a table of values? Well, I'll help you with this. To make a table of values, yes, any 2 points will make a straight line. However, if you make a mistake, any 2 points make a straight line, and it might not be the right straight line. So I prefer 5 points. If you do not have an equation that contains a fraction, the easiest 5 points to use are negative 2, negative 1, 0, 1, and 2. If you're given a table that has values in it, then use the values that you're given. If you're not given a table that has values in it, then I would use negative 2, negative 1, 0, 1, and 2, unless there's a fraction in my equation. If there's a fraction in my equation, I'll tell you how to deal with that in just a minute. Now, what you're going to do is every time you see a number like negative 2, you're going to substitute back into the equation y equals 2x plus 1 and solve for the missing variable y. So my equation is 2x plus 1. I like to put that in the middle here so that I can find it. So now it says, when x is negative 2, so I have 2 times negative 2, which is negative 4, plus 1, which is negative 3, which means when x is negative 2, y is negative 3. That's what I'm doing. I'm solving given different input values for x. Before, I only gave you one input value for x. Now I'm giving you 5 input values for x for the same linear equation. So if we look at the second part, if x is negative 1, I have 2 times negative 1 plus 1. 2 times negative 1 is negative 2, plus 1 is negative 1. If I plug in 0, I have 2 times 0 plus 1. 2 times 0 is 0, plus 1 is 1. If x is 1, I have 2 times 1 plus 1, which is 2 plus 1, which is 3. If x is 2, I have 2 times 2 plus 1, which is 4 plus 1, which means it's 5. Now I'm going to graph these ordered pairs. I have 5 ordered pairs. Essentially, I have negative 2, negative 3, because I took the value for the x and the value for the y. Then I have negative 1, negative 1. There's the second ordered pair. 0, 1. As you can clearly see, I'm taking the value for the x and the value for the y to get my ordered pairs. Then I'm going to graph those ordered pairs. And I'm going to graph negative 2, negative 3. Start at the origin. Negative 2 is left 2. Negative 3 is down 3. So there's negative 2, negative 3. Holy cow, this is not graphing one. Then I have negative 1, negative 1. Negative 1 is here. I've got to reorient my board just a second. Got out of orientation somehow. Pardon the strange thing in the middle of the video. There we go. Let's replot these points really quickly. So I have negative 2, negative 3, which is here. Oh, so much better. Negative 1 down here. 0, 1 is right here. 1, 3. 1, 3 is right here. 2, 5. 2, 5 is right there. Now you will need to use a ruler to connect your points because I'm very specific and very picky. I can't put a ruler on my smartboard because it will just make a whole bunch of weird, strange things all over it. But I can make a line. Okay, I'm going to put a line on my board here, and I'm going to connect these nice and neat and tidy with a straight line. Okay. If it's not exactly perfect, I can adjust my line. Just leave it there. 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 There you go. Lock that in place so that it doesn't move later. And the last thing I should do is I should put my arrowheads on my line. And of course I have to label this equation. People need to know what that's the line of. They may not have the slightest clue what that's a line of. So I should write the equation to it. So y equals 2x plus 1. An equation has to have an equal sign, so make sure you put the entire equation, not just part of the equation. And that's a quick, now what this means is anything that lands on this line that I just drew is a solution to the equation. And since this line goes on forever in two directions, I have an infinite number of solutions to this equation. I definitely don't want to write them all. It's way too many things for me to have to write. So that's why a graph is so much better for showing you the solution to an equation. Let's look at the second one. Y equals negative 1/2 x plus 4. Okay, negative 1/2 x plus 4 has a fraction. I told you, when you have a fraction in your equation, you might not use negative 2, negative 1, 0, 1, and 2. I don't because I don't like fractional answers. I don't want to have to graph halves and fourths and thirds. So I'm just going to take multiples of my denominator. My denominator is 2. So instead of saying negative 2 and negative 1, 0, 1, and 2, I'm going to take negative 4, negative 2, 0, 2, and 4 because it makes it really easy. This is negative 1/2 x plus 4. So now I'm just going to plug in my numbers. If x is negative 4, I have negative 1/2 times negative 4. Half of 4 is 2. So this would be 2 plus 4 is 6. Now I'm going to have negative 1/2 times negative 2. Okay, I don't have to worry about the negative signs because the negative times the negative is a positive. So half of 2 is 1. 1 plus 4 is 5. I have 1/2 times 0. Anything times 0 is 0. 0 plus 4 is 4. Now I need to start worrying about my negative signs. I have 1/2, negative 1/2, excuse me, times 2. Half of 2 is 1, but negative half of 2 is negative 1. Negative 1 plus 4 is 3. So now we're going to go with negative 1/2 times 4. Negative half of 4 is 2, but it's a negative half, so it's negative 2 plus 4 is 2. So I have my coordinate pairs now. I just need to graph them. So I will graph these points. I'm going to graph them in different colors because I can. So I have -4, 6, so left 4, up 6. I may have to interpret a little bit because my graph doesn't go up to 6, but that's fine. -5, or excuse me, -2, 5, -2 up 5 is right here. Over left and right 0, up 4 is here. 2, 3, go to the right 2, up 3 is right here. 4, 2, right 4, up 2 is right here. Draw my line. I'm going to draw it with color this time because I like colors. Let's go with a blue line. Okay, so if I draw my blue line here, and adjust it just slightly, mine's a little bit off. We're going to use a ruler. Okay, so I got my line here. I put my arrowheads on my line. The last thing I do is write the equation of my line, which is y equals -1/2 x plus 4. If you plot all your points and they don't all line up, you messed something up. Either you messed up a point or you didn't plot it properly when you went to graph it. Now, what happens, okay, if I have equations that are slightly different? If you use the vertical line test on graphs, that you can see every x value has exactly one y value. This means that the relation is a function. A linear equation is a function unless it's the graph of a vertical line, because a vertical line will not pass the vertical line test. That really makes sense. So let's just think about this. If I have an equation, y equals -3, right here, this equation y equals -3 says no matter what x is, y equals -3. Which means if I made a little x in my table, x could be -1, x could be -5, x could be 0, x could be 4, y is always going to be -3, -3, -3, -3. If I plot that, x is -1, y is -3. X is -5, y is -3. X is 0, y is -3. X is 4, y is -3. This is the graph of what we call a horizontal line. I can actually draw it that I haven't had. Okay, that's a graph of a horizontal line. It passes the vertical line test, doesn't it? It's a horizontal line. If you ever get an equation of y equals something without an x value to it, it's a horizontal line. This line is a function. Okay? This is y equals -3. Okay? This is a function because it passes the vertical line test. Okay, let's look at the second equation. X equals 4. Okay? This says no matter what y is, x equals 4. So if I did another little x and y symbol, x is always going to be 4 no matter what y is. Y could be -2, y could be 7, y could be 4, y could be -3, y could be 4,032. X is still going to be 4. So if I was to graph that, x is 4 when y is -2. X is 4 when y is 7, that's off my graph. X is 4 when y is 4, it's right there. X is 4 when y is -3. Okay, X is 4 when y is 0. This, if you'll notice, is a vertical line. That's the graph of x equals 4. It's a vertical line. So it's not a function. Because it's a vertical line and it doesn't pass the vertical line test. So, if you ever get an equation of x equals something, you get an equation of x equals something with no y value to it, then you know it's a vertical line. A vertical line is never a function because it doesn't pass the vertical line test. And that's all there is for graphing functions at this point in time.